write that down. 4.2, we skip 4.1 because 4.1 is just graphing. Well, you guys should already know how to graph points at this point, so that's why we're completely skipping that. Okay, and our learning goal, which will be for a few days because we're doing different types of graphing, but today our learning goal will be graphing linear equations. All right, and we should know the word linear just means that these are going to be in a line, so that's what we're going to work with in Chapter 4, and then later on in the year we'll work with other types of graphs. All right, so the first one starts off and it says, tell whether 4 negative a half is a solution of x plus 2y equals 5, okay? Anytime that you get an ordered pair, they should be solutions that work in here, because now we're moving into the world of two variables. Everything we've solved so far in Chapter 3 only had one unknown. Now we have two unknowns, okay? So what we're going to do is we're going to plug in the 4, and we're going to plug in the 1/2. And we're going to see, does that equal 5 to tell if it's a solution. And there's going to be lots of solutions, so this will just be 1. Okay, so I'm going to plug in the 4 right here. So 4 plus 2 times negative 1/2, does that equal 5? All right, so we have 4 plus 2 times negative 1/2 would be a negative 1. Agree? And or minus 1, 4 minus 1, or 4 plus negative 1, either way. And that would be 3. 3 does not equal 5, so this is not a solution. Okay? Meaning that if I were to graph this, this point would not be on this line. It would not be a solution. All right. Let's move on to graphing. Like I said, I'm going to be teaching you several different ways to graph this year. So this is one of many. This first method is good because it works for any type of equation I give you. This year, not only will we look at things that have just x's and y's, we're going to look at things that are squared. Okay? When you get into Algebra 2, you're going to look at things that are cubed. So it's important. This method works 100% of the time. That's why it's important. Okay, what I would highly suggest here is I find it easier if you get y by itself. Doesn't mean you have to, but I do think it helps when you're writing or you're doing a table like. Okay, so what I'm going to do is get y by itself. So I'm going to add 2x to both sides. So I get y equals 2x minus 3. Again, you don't have to, but I'm going to have to work this equation over and over and over again. Do you guys remember in 3.8 when I did the Celsius problem, and I said you can either solve the equation every single time or get the variable by itself? That's kind of what we're doing here. All right. For most of our graphing purposes, usually the numbers -2 through 2 are a safe bet to use. Okay? So you guys remember earlier this year, they would always give you the domain. Every time you were doing the problems for today, it gave you the values of x. It's no longer going to give you these. You're going to have to figure them out yourself. But this set right here works 90% of the time. Okay? All right, so what I'm going to do is I'm going to plug in the x in for 2 and figure out what y is. So I'm going to plug in 2 right here. So 2 times negative minus 3. So that would be negative 4 minus 3 is negative 7. I'm just going to do that for each one, just like you did on last night's homework, except I had to figure out my own this time. So I have 2 times negative 1 minus 3, that's negative 2 minus 3, which is negative 5. 0 is easy, and I get negative 3. Do we see a pattern emerging? It's moving up and moving up by 2's, correct? What do you guys notice here? That's a 2, and it's a positive 2. Do you think there's a coincidence there? Yeah, there's a reason there that's doing that, so that's a good thing. All right, so if we increase by 2, we get negative 1, and increase by 2, and we get positive 1. Okay, now I'm going to help you graph this on graph paper because I need to break you guys of this like box thing that you're making. Okay, So I'm going to come over here to graph paper so it looks just like what you're doing. And now we're going to graph our table. Okay. Now I'm going to make a mental note here. I need to be able to go over to -2, and I need to be able to go all the way down to 7. So when I set up my graph, I don't need a ton of positive space here. So I might make it look something like this. Okay, that's what I should see. We can go ahead and say, put my arrows in here because these will go on forever. Sometimes I wait until the end to put my arrows. This is my y-axis. This is my x-axis. All right, so now I'm going to graph -2, -7, so over -2, down 7. Okay, what is cool about this is if these don't fall in a straight line, you've done something wrong because all of these are linear graphs. Okay, so after I get them all pointed, then I'm going to go ahead and now I have to draw a line because it said I'm graphing the equation. I'm not just graphing points. These are the points I chose. I could make this graph go on for infinity. Okay, so now I'm going to go back and I'm going to extend my line out just a little bit above and below. I'm going to put arrows on both ends because this line goes on forever. And now I've graphed that equation. Good? Does that make sense? Are you recording your lesson for Carter? I sure am, because we really care about Carter. Hi, Carter. Yeah, Carter. Hey, Carter. Love you, babe. Come at the end. Love you, bud. I don't know, right. I was my sheet. Okay, come back and I'll say it. All right. So now let's look at special types of lines, because this will happen too. Special types. All right. So when I look at this first one, this says y equals 2, and we're also going to look at x equals -1. All right, so when it says y equals 2, I want you to imagine that you have a table, and what that means is every single y value is 2. So everything, 2, 2, 2, 2, y never changes. Y is always 2. Okay, now you have to put in your own x values now, and what x values did I say were good? -2, 3, 2. Yes. So I can still put those in, but y is 2. And so now we start to graph that. And again, I'm going to go to regular graph paper because I'm going to try to break you of making those boxes. All right, so if I go over to my graph paper, I'm going to mentally think, okay, I need -2 through 2 on my x, which is this way, and then I only have to go up to 2. Okay, so I'm going to come over, make a line this way, line this way, and then I'm going to start graphing. So over -2, up 2. Over -1, up 2. Over 0, up 2. You should notice the pattern. Very good. Okay? So this will make a horizontal line because it's always going to be 2. Okay? Now, remember earlier in the last one I had you guys label this is your y-axis. Look where it crosses. It crosses the y-axis at 2. So this is a y equals 2. That's how I always remember it, that it's going to go through the y-axis at 2, so I know it's a horizontal line. Now, you do not have to create tables for those. I'm just showing you why it happens. Okay? All right. So what is your theory? What do you think, or your prediction? What do you think is going to happen with x equals -1? Go on. Well, they're all straight lines.
I think.
A horizontal line, Davis?
I think that.
Straight down, so a vertical line? Okay, so let's look at the next one then. So if I get an x equals -1 equation, that means that every single x value is -1. All of them. Okay, so it does not matter what I put in for y. I can put in -2, -1, 0, 1, and 2. X is still going to be -1. Okay, so if I go over and graph that on my graph paper, so if I go over -1 and down 2, it's here. If I go over -1, down 1, it's here. Over -1 up 0, it's here. And see, there's your line going in right there. It is a vertical line. The vertical line is crossing the x-axis, because this is your x-axis, and it's crossing it at -1. So this is the line x equals -1. Okay? And that is all we are learning